hard lesson today. I didn't understand tangents at all, what they were, their theorems, or how they related to circles.
Me either. I didn't understand how you can draw a common tangent to two circles. Then there are circles that are non-tangent. Does this remind you of any diagram in class today?
Yeah, it kind of reminds me of that diagram.
There was a circle, and a point was placed outside of the circle.
Yes, and the teacher had connected two tangents to the circle and the point.
There were a couple theorems about circle tangents, but I have a hard time remembering them. I'm not even sure what a tangent is.
That's easy.
A tangent is a line, ray, or segment that intersects a circle in the same plane at exactly one point, known as the point of tangency. One of the two theorems is just basically how to identify tangents. To be a tangent, a line must be perpendicular to the radius at the point of tangency. Its converse is that if a line is perpendicular to the radius at the point of tangency, then it is a tangent.
What about the other theorem? Is that the one where you use equations?
Yes.
Here, look at my ice cream cone. If two segments are tangent to a circle and meet at the same exterior point, then they are congruent. We use this theorem in class to identify tangent lengths and variables. For example, let's say you were given a problem with two segments that meet at the same exterior point and are tangent to a circle. If you were asked to find the value of x and were given lengths of both the tangents, you would use this theorem to know that the tangents are congruent. To find x, you would set the lengths equal and solve. To solve, set the tangent lengths equal to each other. Then, isolate x by subtracting x from both sides of the equation. After that, add 7 to both sides of the equation. The answer should come out to be x equals 7.
I'm not really sure that's true. I'm pretty sure there are some tangents out there that meet at the same exterior point, but are not congruent. I want to prove that this theorem works.
Okay, fine. I'll measure our ice cream cones, both sides, just for good measure. My cone is 5 inches, and then on the other side, right across, 5 inches. Exactly.
5 inches on this side, and then when I turn it on the other side, it's still 5 inches.
Even if the common point that two tangents meet at moves, the tangents will always be congruent.
I get it now. I guess that's why it's a theorem, because it's been proven to work every time.
Is there anything else that you don't understand?
Just one more thing. Why are non-tangent circles non-tangent circles? For example, you could always make at least one tangent with a circle.
You know what a common tangent is. Remember, it's a line, ray, or segment that is tangent to two circles in the same plane. Common external tangents are common tangents that are tangent to two circles but do not cross the space between the circles. And common internal tangents are common tangents that are tangent to two circles and cross the space inside of the circles. Two circles that touch in one spot have only one common internal tangent, and that spot they touch is where the one point of tangency is located. Two circles can have several common tangents, but just having common tangents doesn't make them tangent circles. They must have an internal tangent that shares one point of tangency on both circles.
Oh, I see now. Well, I guess it's a good thing we went confronted today, or I would have never understood the lesson in geometry.
Alright, let's eat this before it melts. Okay. Let's go, Mary. Victoria.